Hi, for today's tutorial, um, we will connect this circuit diagram into a 2D image on how we will connect based on this circuit diagram. And let's do this. We'll create a 2D simulation and connection. So in that case, we will need branch circuit protection, magnetic contactor, thermal overload relay, um, three-phase motor, another circuit protection, circuit breaker, another circuit breakers, push buttons, and indicator lights. Of course, a transformer. So in order to simulate this in 2D, we will look for this 2D symbol. In that case, we'll need a circuit breaker, which is a three-phase circuit breaker, to the image, and we'll need a magnetic contactor and thermal overload relay, and of course a three-phase motor. So we will label this one as QF1, KM1, F1, and M1. QF1, QF1, KM1, label this as F1, label this as, okay. So we will connect this, since in real scenario, the magnetic contactor and thermal overload are uh, can be connected or can be separately connected. We need to turn off this 135 since they are connected in 246. 135, okay, 246, 246, okay. So we'll connect in this scenario. Let's do this. Okay, we need that one, line one, course the terminal one to U1, and line 3, line 3 to T3 to W1, and the yellow one, the line 2, connect to the line 2 and to V1. For this one, we'll connect this like this. Since they can be connected uh, internally, external connection. So this is our power circuit diagram based on our power circuit diagram here. We have a circuit breaker, the magnetic contactor, the thermal overload, and the motors. So we copy this one. So motor feeder. This is the branch circuit protection. This is the motor controller. This is the thermal overload. Of course, this is three-phase motor. Next thing is we will create our control circuit protection. We'll create the control circuit protection. Look for circuit breaker. We need single phase. Okay. We label this one as UF2, and we need another one here. So we need transformer. So we need a transformer, but it seems there is no transformer our to the image, so we'll stick to the we'll stick to this one. Use a transformer here, and then we'll use let's connect this one. Need a blue wire. Is also a blue one. We need to adjust this one. It's also a blue one. Okay. I think we need to adjust this one. It's also a blue one. And of course this is a red one. The line one. And the other line. So this will be our circuit protection, and we need to create this control circuit diagram in our 2D format. Let's connect this control circuit diagram. We need push button, a 2D push momentary push button, or a 3D one, a greatest 3D one. So this is what we call the momentary push button, the two push button. And we need to make it the red one, and also to the or the 2D frontal image. The red one and the green one, we will label this as S1, stop, and the S2, start. Then we also need um, indicating light. We need an indicator. So we need this one, label this as H1, as the same as this. Label this as start for the run. It's the run indicator. This is, we label this as the red one. This is the stop indicator. Label this as H2. And the yellow indicator, label this as H3. This is the fourth indicator. So These all are the components we need to use in our control circuit diagram. So we'll connect our thermal overload for the line 1. Line 1, this is our line 1 going to 95 and going to 96. So we'll go to 95. Then next to 96. 96 going to the terminal of a stop push push button. It could be interchange. It could be 2 or 1, but I will choose rather for the simulation as 2 instead of 1, or they are the same. So next, this will be connected to um the other terminal of the push button. I can also use this as 2, and going to the other terminal, which is holding coil, the A1. So we will connect this. Let me change the color of the replace this as 1, 2, 3, 4. Okay. We'll change to 1, 2, 3, 4. Or we can also change this as 3 is, I think 3 is, for example, 1. I can also change that. 3, okay. E4 instead of 4, make it 1, 2, 3, 4. Okay. We'll make this as 2. Then we'll make this as 3. Make this as, so that our connection will be the same as here. So we'll make this one also make this one as 3, then 4. We'll make this as 1 and 2. Okay. So then we can change this one to the red one. Okay. Then this one, 2 is connected to 3. Okay. And then we go to the 4, the 4, terminal 4, going back to the terminal A1. It is what we call the holding coil of the, this is the holding coil of the magnetic contactor. Going to A1, then A2 going to line 2. This is going to, this one is going to the line 2. It's connected, the A2. Here is the line 2. So we need to connect this also one, the auxiliary contact of magnetic contactor connected to line to 14 is connected to start push button 4. So it is connected to start push button 4. And 13 is connected to 13. This 13 is connected to 2 terminal 2. So we'll connect this in terminal 2. So this is connected to terminal 2. And also our green indicator is we'll start with the line 2 first. The green, the X2, X2, X2 are connected. So X2, the terminal 2 are all connected. So these are all connected going to this one. So line 2, they are all connected. Line 2. And then our connection here is it must be connected to 14, the green, and this one is connected to um, um, connected to normally close of our magnetic contactor. So this one, the normally close here is 21 and 22. So we can change this one to 21 and 22. These are the connection of 21 and 22, the normally close one, and the thermal overload, the 95 and 96 per hour fault. So for the green push button, it's connected to 14. So there is a 14 here connected here. So this is also connected to 14. Let's connect it in this way. It's also connected to 14. And our stop push button is connected to um, normally close contact, normally close contact. There is an electrical connection here to 21 to 22. So there is a connection here in 22, and 21 is connected to the line 1. 21 is connected to the line 1. Verse 21. 21 is connected to the line 1. Okay. And next is our thermal overload. So 97 is also connected to line 1. So 97 is also connected to line 1. 95 and 96 are connected. So there's a connection here. So 95 and 97 are connected to line 1. For 98, so 98, there is a 98 here. So let me adjust this one so that I have available space here. Okay. For 98, so 98 is connected directly to our fault indicator. 98 is directly connected to our fault indicator, and that's it for our connection. So I have a remaining connection here, the our grounding. So our grounding is connected in our line. So grounding should be connected, and of course we will label this one as transformer 1. Okay, so this our circuit diagram for the start stop operation with indicator light, and this is the actual connection of our electrical wiring for the start operation. This is how we connect our um, control circuit and the power circuit together in a control panel. So let's do the simulation to verify our circuit diagram. We need to simulate this one. So this one, let me adjust the space. This circuit breaker is represent this circuit breaker. So if I turn it on, so the circuit breaker also turn it on. If I turn it off, you can also turn it off. So we need also the same thing with the circuit breaker here. If I activate or energize this circuit breaker on to the image also activate. So our uh, circuit breaker for the control transformer also activated, and this also the QF3 will also activate. Wait, the connection it must be QF3. So let me change this one again. Circuit breaker QF2 activated, QF3 activated. So the red indicator must be turned on. Let me see. So the red indicator activates even though our motor is not yet activated. So it is connected in normally close contact, indicating that the motor is in a stop operation. Once I push this start push button, the motor should run. Okay. So the motor is running here, but on our 2D format, it is not yet activated. So I think there is some connections that our line is not activated. So our fault indicator is activated, reset, You need to stop. Okay. So we'll notice the stop indicator is activated. You need to reset this one. So how is that our motor is not running? So let me stop this operation. So I think our powers going to control circuit is not connected. Since there's no power here, we need to troubleshoot this one. We need to trace up this line in order us to um energize the circuit. Line 2, we need to go back our circuit diagram. So line 1, 96, 95, 96. Line 1 is connected to 95 and going to 96. 96. Let me adjust. Let me simulate again. There is a bit problem here on our 96. There is something wrong here. So it should pass through this connection here. So we'll notice that there is no supply for the 96. Okay. I already see the other one. 95, 96. So what seems to be the problem? Let me just correct it. So 95 and 96 are connected. 97 and 96 are connected to line 1. Line 1. Then 96 going to 96. Okay. We simulate again. We need to on our circuit breaker. So there's no power incoming on our push button. I think there's something wrong here. Okay. Our incoming power is not going to pass through on our thermal overload. So there's something problem here. So this one should or must have the power. Need to stop this one. So connection here. I think we need to activate this one. Let me try to activate this one. So problem in our circuit. So our circuit diagram is functional, but there is something wrong in this 2D image. So our circuit diagram is the same as how we connect. So Even I activate the fault indicator, the fault indicator is, yeah, yeah, activated also, but there's something wrong on our circuit diagram. So the line one must connected here. So there is you see the change color, the brown or the red one. So there is a power after 96, but it seems in our circuit there is no power, but it is connected. Okay. But if we um analyze on our circuit diagram, if we analyze the circuit diagram, if I turn this circuit breaker, so this circuit breaker will turn off. This one will also turn off. This one also turn off. Activating this one. So we'll activate this one. Activating this one activate will trigger the on indicator. This will the stop running or the stop indicator will activate if I turn this one. It's also activate our circuit breaker if I press the push button. So indicating our circuit diagram is on the left side is activating, but in here there is something wrong on our 2D image. It should be running line one. Okay, might be this simulation has a problem on our here. Going to line one, 96, 78, 96. There should be connection in. Let's simulate again. Need to on the circuit breaker or circuit breaker. Seems there's no connection in here. There's a problem in this section. But anyway, um, our circuit is connected based on our circuit diagram created. I think our connection is the way it is. No, it seems to have a problem on this type of 2D image if I simulate. But our circuit diagram, this is how we connect our circuit diagram in the connections controls of control circuit. That's it for today, and thank you for watching our videos for our tutorial. I hope you enjoy watching our videos. Thank you and have a great day.